Welcome to The Explainer. Today, we are going on a really massive journey. We're going to contrast the expanding, mind-bending cosmic chaos of black holes with the purely deterministic, bare metal hardware sitting right on our desks. It's all about why we absolutely must replace infinite complexity with anchored mathematical truth if we ever want to actually automate our physical world. Okay, let's dive into this. Here is our roadmap for today. First, the cosmic complexity problem. Then, the Python's lunch conjecture, the AI wood chipper, the LIFO ledger solution, determinism at index 0, and finally, anchoring physical reality.
Section 1. The cosmic complexity problem. Chaos as a physical law.
So to really understand this, we have to look at how information behaves at the extreme macro level. See, infinite complexity isn't some weird glitch. It's actually completely natural and expected. Suskind's second law of quantum complexity basically tells us that just like closed systems increase in entropy, the computational complexity of a quantum state, say inside a black hole, just keeps growing. It continuously pushes toward its maximum value for an exponentially long time. As particles interact, the information about their initial state becomes wildly and completely irreversibly scrambled. Moving to Section 2, the Python's lunch conjecture, geometric obstructions. Now, what's really interesting here is how this cosmic complexity creates massive roadblocks when we actually try to decode that information. In the holographic space-time model of the Python's lunch, there's a fascinating structure. Notice how on the edges we have these narrow constrictions, but right in the middle, there's a massive, non-minimal extremal surface. They call it the bulge. When information gets swallowed by this Python and passes into this bulge region, trying to reconstruct it from the outside becomes computationally devastating. The physics literally obstructs our ability to easily decode the information. It's trapped. So if you were attempting to slice this wormhole and somehow extract that data, it would require an exponential number of quantum gates. And here is the kicker. Nature handles this infinite complexity effortlessly. But for an observer, for us, trying to compute that data is practically impossible. The sheer computation required scales so far beyond what is achievable. The complexity is just way too vast.
All right. Section 3. The AI wood chipper. When machines guess.
Now, you might be wondering, why does black hole complexity matter to us down here on Earth? Well, because we're witnessing this exact same unchecked complexity rotting our very own digital architecture from the inside out. Get this, right now 80 to 90% of AI compute cycles rely on microscopic hardware approximations instead of exact math. Let that sink in. Large language models aren't calculating absolute truth. They're fundamentally just guessing the nearest mathematical probability. Let's trace this right down to the silicon. To process all this data at blistering speeds, the hardware uses something called a floating point unit, or what we can call the FPU gambler. It estimates complex math using proprietary tables, and in doing so, it constantly drops tiny fractions in what's known as the 23rd bit shop. Think of this FPU like a giant blender. You know exactly what fruit you put in, right? But once it spins, there is no way you can reverse engineer the exact original fruits. The forensic chain of title is just gone, permanently destroyed. The human author is quite literally liquefied.
So, here is the stark dichotomy we're facing. On one side, you have quantum and AI complexity. It's wet, it's probabilistic, built entirely on FPU guessing, and expanding into chaos just like the interior of a black hole. But on the other side, if we actually want to automate physical systems reliably, we desperately need dry, anchored reality. We need absolute mathematical truth, and that brings us straight to LIFO determinism.
Section 4. The LIFO ledger solution, anchoring to reality. So, the crucial point is that we absolutely cannot rely on fuzzy AI logic to control real-world machines. We can't float off into the digital ether. We desperately need a grounded anchor. Our source material points directly to the LIFO JSON state tree, which is governed by the ERC 7827 protocol. LIFO, meaning last in, first out, transforms lightweight JSON into a rigorous, bit-perfect smart contract layer. It completely bypasses that expanding complexity and the massive hidden taxes of traditional software auditing by strictly structuring exactly how data is recorded and verified. It's mathematically pure.
And wow, the engineers behind this do not mince words. In the ERC's 7827 source documentation, it aggressively states the old upside-down tree is apostasy, a heresy, that has to be purged to achieve true physical automation. That's intense, right? They are violently rejecting the chaotic, floating, event-driven structures of the past. To manipulate physical hardware flawlessly, you just have to purge the ambiguity. No exceptions. Section 5. Determinism at Index 0. The Digital Bouncer.
And this brilliantly illustrates our core mechanism here, the SYN kernel function. Imagine a highly efficient, super strict bouncer at a very busy club. This bouncer doesn't waste time scanning the massive history of everyone waiting in line. No, they only look at the ID of the person standing directly in front of them right now, at Index 0. The sequence is totally rigid. Thesis, check if the space is empty. Synthesis, if it's empty, synthesize the new data directly into that slot. Antithesis, if data already exists, the bouncer violently rejects the conflicting input. No entry, no accidental overwrites, just single entry perfection.
This strict, deterministic elegance means that the system only ever needs to query the absolute top of the stack to get an immediate, flawless mathematical proof of the entire system state. There is zero ambiguity here, folks. You don't have to decode a Python's lunch. You don't have to rely on some FPU approximation. The state is either mathematically true or it isn't. It compresses all that fuzzy logic down into pure, undeniable math. Section 6. Anchoring Physical Reality. Digital Exactness. Let's move on and see how this builds into concrete reality. How do we bridge this bit-perfect digital state down to physical hardware, like, say, a FlowX42 cheerbot? Well, it's done through the ingeniously simple HTTP 402 loop. Because our state is firmly anchored, the server doesn't panic and resort to fuzzy logic. It's just 3 simple steps. Step 1, the server triggers a 402 status demanding proof of payment. Step 2, an autonomous edge agent natively signs a cryptographic proof. Step 3, the client retries the request with the receipt, instantly unlocking the physical resource. It is a beautifully simple, deterministic loop that completely safely bridges digital commands to physical execution, bypassing the fog entirely. We've seen today how the macro universe naturally defaults to infinite complexity, and how our current digital architecture is actually mimicking that chaos, slowly blending human truth into untraceable noise. The LIFO ledger is the anchor pulling us back to deterministic reality. But as the clock ticks on the open web and the AI woodchipper continues to consume unanchored human data without perfectly crediting its source, I want to leave you with this final provocative thought. If an answer engine mathematically eats its own food supply faster than it can be replenished, what happens when it finally runs out of things to say? It's a stark reminder of exactly why mathematically exact property rights matters so much to save the open web. Thank you so much for joining me on this explainer. Keep learning, keep questioning, and I will catch you next time.